Hi everyone. So I thought what I would do is just make a quick video kind of going over something that I think is causing a little bit of confusion now that people are running the computations, right? So primarily has to do with the acetamide calculation, right? And so you can kind of see that molecule right here where we're just simply looking down that carbon-carbon axis right now. But one of the things is that people are running into is that when they're doing their frequency calculation, for some people, right, they're getting a single negative mode. Usually, I think it's around negative 60, wave numbers in those cases. And so then, what you have to do is you have to rotate the molecule and then you do it. And then, suddenly the negative vibration goes away, right? And so the thing to think about is when you're doing a geometry optimization, the way that the software recognizes whether to stop optimizing the geometry is that it takes the second derivative of the change in energy, and once that is basically zero, right, the slope of that is equal to zero, it assumes then that it's at an energy minimum, right? And so if we think back to concepts from Orgo 1 and well, I guess it would be Orgo 1 and 2, right? Where you're thinking about, a conformational analysis where you're thinking about, if you rotate, some conformations are going to be more stable, some are going to be less stable because of repulsions. And so what I did is I ran a calculation where I actually scanned the rotation of that methyl group to kind of show, what happens, right? So I'm just going to animate it right now so you can look down here, that methyl group, and so you can kind of see how, the hydrogens on the nitrogen, group kind of, sway back and forth. And the nitrogen moves a little bit in those cases, right? But the methyl group is going around and rotating and rotating and rotating, right? And so, depending on where you're at when you're doing the geometry optimization, right, it's going to, depend on like where everything kind of moves. And that's, what we're trying to do with these calculations, right, is to get more towards a more accurate depiction of what's going on. And so if we look at the scan graph that we have right here, where we're looking at as everything changes, right, we can see, the complete energy minimum, we can see the highest energy points and everything. And so, the highest energy point, the lowest energy points, those are the ones, right, the max and min is where you're going to be getting the, when it does the geometry optimization and it takes that second derivative, right, you're going to get a slope of zero. When you're at the maximum point, right, one of your vibrations is going to be a negative vibration, right? And so it's going to be an imaginary mode, and that has to do with the fact that that is, a transition state, right? So thinking back to transition state theory, right, when you're at the maximum, you're basically just changing one, vector, right, one movement of an atom, whether it's, opening up a bond angle or rotating something or, stretching out an atom. When you think about, kinetics and transition state theory, right, the maximum is going to have, an imaginary mode in those cases. And that's what you guys are seeing when you're seeing that negative 60, is that you're actually at one of these maximum points right here. And that you're actually, not where you're supposed to be. And all it takes is just rotating it, a little bit, and then you start, going downhill, and then you should end up at one of these energy minima right here, right? And so there's, a few different options. I would disregard this part right here just because it should be pretty similar, right, for all three of the peaks and valleys, just simply because of the fact, right, that the hydrogens are all exactly the same, and so that should happen, right? But if you're looking at it, right, you can kind of see a trend here too, right, where there's going to be a slight energy dip right here, and that has to do, right, so if we look at the difference, so this is what, 0.46 and 0.47, so if we look at 0.46 and 0.47, oh man, that's going to be a nightmare. Wait a second. What's the angles? Negative 48... negative 53, negative 48, negative 53. So, right, so if we look at those right here, so negative 48, right, is this part right here. If we go to 53, right, you start having that, and that's when you're, kind of going over the, the miniature bump of that right there, and you just keep moving in those cases, right? And so then you end up with different peaks. And so, if we were to look right here and do like the true minimum that we're getting right here, right? So let's just say that, right? So that's at 43 degrees, right? That would look, right here, right? And so this is what you guys are probably getting then when I ask you to, rotate it by 50 or 60 degrees, right? Because if we go, right? So this one is probably roughly up, I guess, what, 134, right? So if we look at the max here, so we're at like, 209, negative 134, right? Up here, that's, 130 something, right? So if we're looking at this, it's 2.35, right? So 2.35 is right here, right? So that's where you guys, I think, are always ending up, and that's where it's the negative 60s coming from to kind of rotate those two things. So, one thing, so when you're doing calculations, right, this doesn't look very smooth, and that's because I'm not going to go, we're not in this class, we're not going to learn how to do these coordinate scans. If you want to learn how to do them, right, feel free to reach out to me. It's not that hard to set up necessarily, right? You just have to pay attention to a few things and think about, the underlying chemistry and a lot of the concepts when setting it up. But, in terms of what the commands are, it's pretty straightforward. But we're not going to learn it in this class. So, but if you want to do it for fun and be like, oh, this would be a cool thing for something else that I'm working on, right? Let me know. But essentially, right, what we're seeing in these cases, right, is that you guys are, some of you are, the geometry is ending up getting caught up here, and you have to just simply nudge it so that it goes down to here. And that's what you're doing in those cases, right? And that's what, the most common thing really is anytime you have those negative modes is that you're just getting caught up on some kind of, hill somewhere, and it's not, moving its way down to here, right? It's just simply stopping at that point because, again, the geometry optimization, to determine when it's been optimized, it takes the second derivative and it looks at the slope, right? And if the slope is equal to 0, right, it's telling you that you're either at the top or the bottom, but it doesn't know whether it's at the top or the bottom, right? You have to be the one that looks into the data and be like, is it the top or the bottom? Yes, no, yes, it is. Okay, let me just, try to figure out and change that. No, okay, we're set. So let's keep, we can keep it moving and everything. So hopefully this was informative in terms of why that's happening for some of you, and where that's coming from and why it seems to be, pretty prevalent from what it seems like with the acetamide, in these cases. So, right. I mean, here's the molecule and stuff. So, but yeah, so that's that. Hopefully this was informative.